If we carry out this series reaction in the batch reactor, as the time progresses, the number of moles of A, R and S will vary. This means to say that composition varies with respect to time. We are going to look at how composition varies in the batch reactor when you carry out this series reaction. We will assess composition in terms of Ca, Cr and Cs versus time. In order to do this, we will conduct this series reaction hypothetically in a batch reactor and use intuitive thinking to arrive at composition variation. So there are no complications of mathematics as of now. Let us first understand batch reactor. It is simply a vessel into which the raw material or reactants are charged, allowed to get mixed and hence react to form products. After some predetermined time, the reaction mixture is taken out. For our hypothetical experiment, we will take some liquid as charge that contains only A. There is no R and S present in the raw material. We will make plots of Ca, Cr and Cs versus time on this graph. Let us formulate some ideas to plot Ca, Cr and Cs versus time. Since we are taking only A in the raw material, there will be some value of concentration of A which we call as Ca0. At time t is equal to 0, when charge is just fed into the reactor, concentration of A is, let us say, 1.5 mole per liter. The point is shown here. As the time progresses, A is going to react, therefore Ca will start decreasing. Another point to be noted is, if we allow this reaction to take place for sufficiently long time, Ca should fall to 0. Using these two ideas, we can approximately draw Ca versus time. Approximately meaning qualitative assessment only. This is how it looks. For this case, Ca falls to 0 sometime between 25 and 30. How steep is this curve and when Ca becomes 0 depends upon the values of Ca0 and K1. Let us understand the variation of Cr. We know one point on Cr versus time curve, that is at time t is equal to 0, Cr is 0. The point is located here. If you look at the reaction, it is obvious that there will be no R at some time sooner or later if we allow this reaction to take place for sufficiently long time. Thus there is one more point where Cr is 0. Let us say for this case it is somewhere here. Thus we have 2 points on the curve, point 1 and point 2. We also know that there is some finite concentration R between these 2 points, starting point and ending point. We have no choice but to draw a curve like this. R increases first, reaches a maximum and becomes 0 in order to include the points already located, point number 1 and point number 2. Where this maximum occurs will depend upon K1 and K2. Now lastly, Cs versus time. We know that at time t is equal to 0, Cs is 0. Locate one point here on Cs versus time curve at the origin. As per the reaction, S is continuously getting formed. Therefore, Cs keeps on increasing. The variation is shown as a curve here. Will it keep on increasing forever? No. Formation of S should stop when Cr becomes 0, as there will not be any reaction. In fact, when Cr becomes 0, Cs curve will become flat asymptotically. This is how we can qualitatively assess how composition varies in the batch reactor. One quiz question. What is the ultimate concentration of S and Y? Think and answer. In this session, we discussed how to assess qualitatively composition varies with time in the batch reactor when the reaction A giving R giving S, that is series reaction, is carried out.